parallel circuit, two light bulbs connected in parallel. This is our diagram. I need a circuit with a switch that would open and close current through everything. The two light bulbs should be parallel to each other. So remember, parallel light bulbs, if I take one of them out, the other one should still be on. So I unscrewed this light bulb and this one is still on. This switch is on. This light bulb is still on. If I take this one out, light bulb still gets current through it. And then if I should take this one, the lower light bulb should be on. Shall we try? Boom. Yes, works. However, if I go ahead and open the switch like I did here, there is no connection between these two wires and our circuit is open and therefore neither one of the light bulbs is on. So that's your parallel circuit with switch which is in series with them. In order for us to determine specific values that we need to find out in this lab, we need to measure the voltage on the battery. Therefore, I'm going to use voltmeter on the battery and a total current. So remember, if I were to draw my direction of current, the entire current goes like this, and then over here the entire current splits. Part goes here, part goes here, depending upon which one of them is more resistive. The more resistive one will get less current, and then right here, this junction, both of these currents will unite and get me the total current. So this will be the total current in the entire circuit. How do I find my equivalent resistance? Well, total voltage, which will be the voltage of the battery, and technically for a parallel, it will be the voltage on either one of them, divided by I total. That will be my total resistance, all right? So that is what is asked of you in part 1. You need to figure out the total resistance, and you need to measure the total current and the voltage on the battery. So there we go. I connect my prongs from the voltmeter. Again, I know it's voltmeter C because it's right here and it's red is on the right. And I just put these prongs straight into the battery. A lot of dropped voltage compared to the actual battery. I'm still using the same battery. That is because we have lots and lots of current going through it. So a lot of the total voltage of the battery goes into the housekeeping. So that is how you measure your voltage. And now we need to measure the total current. Now, so if I follow the current, it goes like this through the switch right here, then it splits between the two light bulbs. Part goes here, part goes through this, and then they all reunite over here. So in order for me to measure the total current, I need to put my ammeter somewhere between the battery and the cluster. That's what I did. I took this part of the wire from the battery, connected it to the prong of the ammeter, and then the other prong of the ammeter I placed where the red wire used to be. So now all the current is still going through, and the entire 0.36 amps is total current. Total current is 0.36 amps, where voltage was 2.40 volts. So then my equivalent resistance is going to be voltage over current, which is 6.67. So it's going to be 6.7 ohms. Remember, this is the smallest possible. So the individual resistances of the two light bulbs is going to be bigger. It is 6.7 because in parallel total resistance drops. Now in the next part, in part 4, we need to figure out specific resistances of their separate light bulbs. In order to do that, I am only allowed to, so technically I already measured this. So this already is known. That's 2.4. And I'm allowed to measure now an individual current through just light bulb number 2. Measure only the current through this light bulb. I need to connect it so that if I don't have this ammeter, this is dead, but this is still on. So let's go back to the original. This is how it was constructed. So this is my parallel cluster, that is my switch, and that is my other wire. So again, parallel cluster, switch, wire. Now I need to disconnect either this wire or that wire from my light bulb, connect ammeter into that string. See how my first light bulb was still getting current, and only this one is not, because I took this wire from it and now it's open. But this side is still getting current because it's parallel to this one. So if this is broken, that still gets our current. And then as soon as I put my ammeter inside, this is on. So and it's only 0.17 amps. So that is 0.17 amps. Then I know that 2.40 volts was the voltage. And if I divide that by my 0.17 amps, 14 ohms. What is the current in light bulb 1? I know that the total current is 0.36. So if I subtract 0.17 from it, I should get the remaining 0.36 19 amps. 2.4 over 0.19, 13. A little bit different from the previous one.